Okay, so today we are going to talk about some more proofs, and out of a time constraint of only 15 minutes in this video, the first two flowchart proofs are printed on the notes that I've uploaded, but they are not in this presentation. We're going to just jump right into the proofs that you have to write out yourself. So there's a couple theorems here. The first one is the right angles congruence theorem. Pretty straightforward. It means all right angles are congruent. They're all equal to 90 degrees. There's actually a theorem that says that. We all assume that, but we're going to use that today. And then also the congruent supplements and congruent complements theorems. So what that means is if an angle is either complementary or supplementary to another angle, then if there's something else that is complementary or supplementary to that same angle, then they're congruent. So like in this picture on the top here, angle 1 and angle 3 are both supplements to angle 2. And so that means that angle 1 and angle 3 are congruent. Same thing down here. If we know that 4 is complementary to 5 and 6 is complementary to 5, then we know that 4 and 6 are congruent, angle 4 and angle 6, okay? So we are going to look at this diagram. We're going to look at our givens and we're going to write a proof, okay? I'm going to talk through a couple of really important points here. So first thing is, if you're given statements, those should be your first two statements here, and given should be your reason. I have a tendency, if I'm writing proofs myself, to separate these into two separate statements or put them on the same line. I don't know. Sometimes I choose to do it one way or the other. It doesn't really matter as long as you're writing down those givens and giving the reason of given, okay? The next thing is, in a statement, if you have a vocab word like supplementary or vertical or anything like that, that is almost always going to show up in the reasons later on in the proof because most of the time you're given that information because you need it for something. You're not just told something supplementary and then you don't need that information. You're told these two angles are supplementary so that you can use that as a reason to write another statement and then prove from there. Okay? So first thing we're going to write here is angle 1 plus angle 2 equals 180 degrees, and angle 3 plus angle 2 equals 180 degrees. And the definition of supplementary is our reason there. And that's because we can say that when you add those two angles together, they equal 180 because they are supplementary. Okay? So if we didn't know they were supplementary, we wouldn't be able to make that statement. All right, the next thing that we're going to look at here is somehow, some way, we're going to want to get all those into one equation so that we can get angle 1 and angle 3 equal to each other. So, and really and truly this is more correct with the measure of each angle. So I see they're both equal to 180, and I know this property that I can take those two things, so the measure of angle 1 plus the measure of angle 2, and then set it equal to the measure of angle 3 plus the measure of angle 2. And that's the transitive property. Okay, and that's because I can take those two things that are both equal to the 180 and set them equal to each other, because if they're both equal to the same thing, then they're equal to each other, and that's called the transitive property. Okay, and then I notice there's an angle 2 on both sides here, so I can subtract that from both sides and say the measure of angle 1 equals the measure of angle 3, and that's the subtraction property of equality. Okay, and then angle 1 is congruent to angle 3. Okay, and so that's the definition of congruent angles. Okay, and that's because they have the same angle measure, which means they're congruent or the same. Okay, so we've proved the statement. That proof statement should always be your very last statement in your two-column proof. Okay, and then your reason is how you got there, that last step. Okay, a couple more things for you here. So if two angles are a linear pair, then they're supplementary. We've actually talked about that before, but a linear pair is a set of supplementary angles that are adjacent. And that's kind of how we talked about it in chapter 1. And then the other thing is vertical angles are congruent, which we also talked about, is that vertical angles have the same angle measure. So we are going to jump right in and use some of those. And we're going to write our own 2-column proof this time with no statements or reasons to start with. And we're not going to know the number, so we're just going to give it a go. So I'm going to write the first statement, and I'm going to say angle 1 and angle 2 are complementary. And that's given. Okay, and statement 2 is angle 1 is equal to 37 degrees. And again, that's given. I tend to separate them most of the time just because I like to see them as two separate statements. Okay, so the next thing we need to do is think about, okay, our goal is to prove that angle 2 is equal to 53 degrees. To get there, I should probably use these given statements, because we're not going to be given statements if we aren't going to use them. Okay, so I'm going to look at that first one and I'm say complementary. What does complementary mean? Well, it means they add up to 90 degrees. So I can then make a statement about these two angles. If they're complementary, I know the measure of angle 1 plus the measure of angle 2 is 90 degrees. And that is because that's the definition of complementary angles. Okay, so because we're given that, so again, if it shows up in the statement, a lot of times it'll show up in a reason later on. All right, and then I can say, oh, but I also know that the measure of angle 1 is 37 degrees, and so I can substitute that in to figure out what angle 2 is. So instead of the measure of angle 1, I can say that, 37 plus the measure of angle 2 equals 90 degrees. And again, I substituted that in, so the reason here is substitution. And then for 5, I can subtract 37 from both sides, and I get the measure of angle 2 is equal to 53 degrees, and that's what I was trying to prove, is that angle 2 is equal to 53 degrees. Okay, and so the way I got there is then we used the subtraction property of equality. And I've proved what I needed to prove in 5 statements and 5 reasons. Okay, let's look at another one. All right, so here we don't have any givens. It just says write a proof to, write a 2-column proof to justify your reasoning, and we're trying to find the value of x, okay? But we are given this diagram. Well, that's almost like having givens, okay? So I'm going to start with the fact that I know that angle QPR is equal to 3x plus 1 degrees. And that's actually given, or we could say it's in the diagram. Okay, I also know by looking at this diagram that angle TPS is equal to 148 degrees. Okay, and again, that's given and labeled in the diagram. Well, and then I look at these and I'm like, oh, hey, look, QPR and TPS, they're vertical angles. So I'm going to say, okay, vertical angles means that they're equal. So QPR is equal to TPS, angle TPS. I have those angle symbols there. And I know that because they're vertical angles, and all vertical angles are congruent. Okay, well, now I know what QPR and TPS are equal to, and I know they're equal to each other, so I can substitute both of those things into this equation. And I can say 3x plus 1 is equal to 148. And I substituted in both of those values. It is not the transitive property because they're not both equal to the exact same thing. we're substituting from two different equations and we're substituting them for two different things. Okay, then I'm like, oh hey, this is an equation I can solve. So I'm first going to start by subtracting 1 from both sides. So I'm going to get 3x equals 147. Okay, so that's the subtraction property of equality. And then I can divide and get that x is equal to 49 degrees. Okay, and then my reason for being able to say that is because I divided, so it's the division property of equality. Okay? All right. One last thing that we're going to talk about is how to solve for missing parts and angles today. Not necessarily a proof here, but what we're going to do is we're going to try and find the value of x and the value of y. And if I can do it quickly enough, I'm going to try and show you a couple different ways to solve for y, because sometimes, given the information, you want to have some other tools in your toolbox to be able to do that. So first of all, we're going to solve for x. And I see that 4x and 6x minus 26, these two angles here are vertical angles. So I'm going to set them equal to each other. Then I'm just going to solve this equation. Oops, minus 6x, not 2x. And then I get negative 2x is equal to negative 26. Divide both sides by negative 2, and I get x is 13. Okay, so the easiest way, since there's a y right here and a y right here, and these are vertical angles, would be to set them equal to each other. But sometimes, just sometimes, we're given only the x values, and then you're not given this angle. And so I'm going to solve this first way, first finding y, and I'm going to pretend I was not given this piece here. I don't know that that's 7x minus 12. The only thing I know is 4x and then the 6y, but I now know that x is equal to 13. So I see that 4x and 6y plus 8, those are supplementary. They're a linear pair because they add up to 180 degrees. So I can write the equation 4x plus 6y plus 8 equals 180. And I can do it that way because, again, I know they're supplementary. And I also have figured out that x is 13. And so I can then plug that in for my x and then solve this equation from here. And if I do 4 times 13, that's 52, plus 8 is 60. So I get 6y plus 60 is 180. So 6y is equal to 120. So y is 20. Okay, so that's a tool if I don't have this piece here, the 7y minus 12. But you could also see that, oh, hey, these are vertical angles, and solve it that way. And just do 7y minus 12 is equal to 6y plus 8, because we know vertical angles are congruent. Subtract 6y from both sides. Add 12 to both sides, and we get y is 20 that way as well. So you can see we got the same answer both ways. Okay? You could also set up an equation and say 4x plus 7y minus 12 equals 180. Or you could use this and set up a number of different equations as well, using those linear pairs. So I just want you to be aware that even if you're not given all 4 angles, you can usually solve for one variable and then use that to find the other one. Okay? We are going to do chapter 2.6, Big Ideas assignment. Tomorrow we'll do some review. Monday we'll do some review. And then Tuesday next week is when the test will be posted. Let me know if you have any questions.